Push that rock here with Simpson Math, talking sinusoidal waves. Now in our previous video we graphed sine. This time I want to graph cosine. So the thing about cosine, you have to remember the inputs are the angles, like pi 12ths, but later we're going to learn the output for pi 12ths, but we don't know the output right now. But like pi 6, the output would be for cosine root 3 over 2. Because remember, cosine on the unit circle, the definition is cosine of theta is equal to x over r. But if the radius is 1, then it's just x. So you put in this angle, like pi 6, you get out root 3 over 2. Or you put in 2 pi thirds and you get out negative 1/2. So that's the thing you have to remember. Now last time I did sine, I made our increments pi 12 so that I would get 2 12ths here, 3 12ths, 4 12ths, 5 12ths, 6 12ths, so forth and so on. I'm going to go a little quicker this time. I'm going to make my increments 45 degrees, okay? So I'm going to go pi 4s, pi halves, 3 pi 4s, 4 pi 4s, which is pi, and so forth. So I'm going to go by fourths. And I'm going to rely on the fact that I actually know that cosine is going to be very similar to sine. I mean, look at it. It's just sine goes a half, 1 over root 2, root 3 over 2. Well, cosine is root 3 over 2, 1 over root 2, and then 1/2. So it's going to be very similar. In fact, cosine is also what we call a sinusoidal wave. So it should have that same look that sine had. It's not identical, but it'll have that same look. So here we go. So I just ask myself at 0 now notice here is a confusing point. The inputs for cosine are angle measures, and the outputs are the x coordinate where that angle, the x coordinate where that angle intersects the circle. But in a Cartesian plane, we let x represent inputs. So this is representing the angle measurements, and we let y represent the outputs. So this is representing the x coordinates. That's kind of confusing. Y is representing the x coordinates where angle x intersects this unit circle over here in this diagram. So it can be confusing, but you just think of this as inputs and outputs. This is the angle measurements, and this is the x coordinates where that angle measurement intersects the circle. And maybe we should just build a table. It's like, let's build a table. Like normally we're thinking of theta, and the output is cosine theta, and here it's x, y. But if I put in 0, then cosine at 0 radians is 1, because it's the x coordinate. Well, so it's 0, 1. And if I put in pi 4, so we know we get 1 over root 2. So it's pi 4, so 1 over root 2, and so forth. And if I put in pi halves, well, then cosine is 0, because at pi halves, right here's pi halves, it intersects the circle at the coordinate 0. And then 3 pi 4s, well, that's going to be 1 over root 2 again, except that it's negative because it's over here. Here's 3 pi 4, so you have to go to the left, so the x coordinate is negative. And then at pi, it's going to be negative 1, because here is pi radians, and it intersects at negative 1, and so forth and so on. So I think we can graph it now. So at 0, I get 1. So 0, it's 1. At pi 4, I get this 1 over root 2. Well, we learned that's about 0.7. So if this is 0.5, this is 0.75. So it's about right there. Then pi halves, we're at 0. And then 3 pi 4s is negative 1 over root 2, which is about negative 0.7. So here's 0.5, here's 0.75, so it'd be about right there. Oh, what am I doing? It's over here. Oh, that's terrible. That's terrible. I was under the wrong, that's terrible. That's the kind of mistake you make that confuses you on what the graph looks like. Then at pi, it should be negative 1. So right here under pi, it should be down to negative 1. Then what is it at 5 pi 4? So it's the same thing it is at 3 pi 4s. So I get this going on here, and at 3 pi halves, well, we're back to 0. The x coordinate at 3 pi halves is 0. So I'm back to 0. At 7 pi 4s, we're back over into positive land. because 7 pi-fourths is in quadrant 4, so the x-coordinate is in a positive direction, so it should be positive 1 over root 2, which is about 0.7, so it's about right here. And then at 2 pi, I'm back to 1. And of course, if I keep going, if I go around to 2 pi, and then I go to the 9 pi over 4, which would land me right back here, I'd be right back to this position. So it's going to go back down. So, and the same thing's going to happen if I go in the negative direction. If I go to negative pi-fourths, I'll be back to this positive value here. So it's going down, and we put a dot, dot, dot to represent that the pattern is continuing. But what does a curve look like? Well, it's a sinusoidal wave. So oh my gosh, I'm missing my points. So it looks like my brother is way better at this than whoa, got a little high there. There, okay, that should be the highest point is 1. So again, we see the period, I should call it the least period for technical reasons, but the period is 2 pi. It finishes a cycle over an interval that is 2 pi units long. And the amplitude is 1 unit. So if I try to be able to cut this wave so that there's a middle line, see how this is -1, that's +1, so there's a middle line here, then I go the distance from that middle line up to the highest point. So from here to 1, so the amplitude is 1. That's what amplitude is. And there's my cosine wave. And it's a sinusoidal wave in shape, but it's the cosine wave, not the sine wave. Math made simple. Sim math.